Hi, good evening.
Good evening, sir.
So I am Ganeshan, Assistant Professor, Department of Computer Science and Engineering. So today we have discussed about the fundamentals of algorithm problem solving. Okay, before that, what is mean by programming or what is mean by algorithm? These are the basic concepts in the field of computer science. Okay, programming is a structure or is a syntax based. Okay, so instruction given to the computer machine to solve any kind of problems, okay, or any kind of task. But algorithm is a instructions, or basic idea or basic abstract idea to solve a problem. Here, the main difference between algorithm and programming is programming we need some standard procedure, but algorithm we don't follow, no need of follow the procedure. It's a simple steps, naturally using our own language, natural language or pseudocode like that. Okay, so currently there are around 8,000 programming languages exist. Okay, very famous languages are very popular one: Python, C, C++, Java. Okay, so in this session we will discuss about the basic fundamentals of algorithmic problem solving. Okay, let's start the session with Mithul Shankar.
Now I am going to talk about problem solving. So when it comes to problem solving, it's not just writing a code, an algorithm. We have to understand the problem first. Then only you can write the algorithm properly. If the algorithm is not in proper way, you will get the wrong answers. Now we have three steps in that. First one is input. In input, if you are giving students marks, and in output we'll get students marks, that is highest to lowest or something mixed sorting. Then when it comes to constraints, same numbers can be repeated. I mean, same marks can be repeated and same subject can be repeated. These are constraints. Then for example, if I want to sort in highest mark, we have two types. One thing is we have to arrange in ascending order and descending order. Second thing is we have to compare one number with other number, then we can find the highest number. So first we have to understand the problem properly. If you are not understanding the problem, you can't solve the problem properly. You are not getting defined output. Thank you. Now my friend Sai will continue.
Yeah. In this algorithm, for the second fundamental, I am going to say about problem definitions and the abstractions. In problem definition, we are getting the what is the problem, and we need to understand it, what type of problem it is and what are actually needed. We need to understand what is the exact problem it is, and we need to take a relevant data about them. And the abstraction is nothing but we are lefting the unnecessary data, and we are keeping important which data is needed for the problem to solve it. So take one example, sir. Google Maps. Google Maps, if you put some destination, it will doesn't care about your who are you, why are you going to that place. It only takes the places like how many times and distance will be calculated. So these types of relevant data can be taken, unnecessary data can be removed. That is called abstraction. We need to understand what is the problem, and by understanding that problem, what are the data we are needed, like relevant data and core logic. Abstraction nothing but it is a real world problems solving using a logical data. So by relevant data, we can say what are the steps can be improved, what are the steps we can use it to easily solve this problem. So these are the two fundamentals. We need to know what is the after the problem that we give.
Once understanding the problem, then we go for stages. What are the
procedure we are putting, and what type of design we are giving, what are the steps we can use to easily solve that problem and do the task.
Okay.
Yeah, next I am going to tell about algorithm design strategies. Once the problem is clear, we go to the design strategies. Some fundamental includes greedy, brute force and the divide conquer. These are the fundamentals included in the design strategies. Brute force is a try all possibilities. If the problem is solved in try in most of the when the problem is solved, we can try in the all when the result is come in all the way. We need to check it. Divide and conquer. The problem into break into a parts. If the one problem is in a many output, we can break the problems into the many parts. Greedy. Choose the best parts. If the problem in it, we can solve the problem in a best way. Dynamic programming stores and reuse the results. These are the dynamic design strategies in algorithm.
Okay, I'm going to talk about the correctness and efficiency of an algorithm. An algorithm must be correct and efficient. Correctness in the sense it should give a valid output for a valid input, and efficient in the sense it should be taking less time and less memory. It can be analyzed by time complexity and space complexity. For example, if we take a linear search and binary search, both are doing the same work, but binary search is faster than the linear search. So we obviously go for linear search. So algorithm is about working smarter.
Okay, now algorithms. Algorithm is nothing but it is a step-by-step procedure to solve the given problem. When the problem is bigger, we can solve it by using step-by-step. And the next part is we should solve an algorithm by using steps like step 1, step 2. The user must be able to understand the algorithm which we are giving. And then the next is the algorithm must be clear and the user must be able to understand the algorithm. And also it is a graphical representation to solve the bigger problem. Every problem will be divided into sub-problems so that the algorithm will be used in an efficient way. Now, I would like to conclude this by saying the algorithm must be error-free.